today I'm really excited because we are thrilled to host Eloi Pereira. He is the head of data science at Car IQ Inc., which is one of our practicum companies this year. But it's a cutting-edge payments platform that connects vehicles, merchants, and banks, enabling seamless and secure transactions. So at the core of the innovative ecosystem that they built is Car IQ's machine identity services platform, which harnesses real-time vehicle data to verify identities and reduce fraud during transactions. So Eloi is going to take us behind the scenes of this platform and share insights into the challenges of building for scalability, ensuring seamless connectivity, and managing the uncertainties that come with real-time data. He has a diverse background in robotics and aviation, and will explore how these experiences shaped his approach to tackling complex issues in vehicle data and payment systems, amongst other things. So I'm really excited to welcome Eloi, and I'll hand it over to you.
Hello everyone. Thanks Elizabeth for the introduction, and thank you all for coming here and hearing a little bit about Car IQ and about myself. It's good to see some familiar faces. I was here a month ago or so on the meet and greet for your practicum, and it's exciting that we are taking two students that they are going to work with us on some of the challenges that I'm going to mention today. So excited to start this collaboration. It's our first time. Feel free to interrupt me if you have any questions. If I see that I'm running out of time, I might just take them a little bit faster. And but at the end, I'm available to stay longer and answer any questions you might have. So this is where you can find me online. I mean, Elizabeth already introduced myself, so I don't need to dwell much about it. But that's where you can find me. So, jumping into it. So what's the problem that Car IQ is trying to solve? So basically, if you have a fleet of vehicles today, ranging from tens of vehicles to thousands of vehicles, usually there's a person that is a fleet manager that is responsible for ensuring that the vehicles get the services that they need. And the first one that is the most needed is fuel. I guess now with EV also charging, but that's the most essential one. But also tolling, parking, maintenance. So there's a bunch of services that the vehicles need, and the way for the vehicles to get these services right now, the de facto solution is to hand a credit card to each driver. Now, this comes with, out of the box, it comes with a difficulty, which is it exposes the company to risk of what is called friendly fraud, meaning that the driver now can utilize that credit card to provide services, maybe not to the company's car, but to its own private vehicle, for example, fuel up his own vehicle, for example, or other sorts of intricate ways that they could use that credit card to purchase stuff for themselves. Now, that also comes, having plastic around, also comes with big difficulties in terms of back office. It's a real pain to manage these cards. If you imagine that you have a fleet of 1,000 vehicles, it means that you might have even more drivers than vehicles. So you might have 2,000 drivers. Now all of a sudden you have to manage all these cards. You need to send the cards to the drivers. By the way, the drivers sometimes are seasonal. So they just join the company for the summer. So all of a sudden you need to hand the cards for 2 months period, and then eventually make sure that the car is returned, which is a pain for the driver as well, but it's also, some drivers might just want to keep it to try to perform some friendly fraud with it. So it's a big hassle to keep track of all these cards. Also, during the payment, the transaction itself, it's also quite painful for the driver. So usually these credit cards, because they want to have some sort of accountability and being able to consolidate all the data, they ask the driver to introduce not only the odometer at the pump, but also the VIN number. Now you can think of like introducing a 6-digit number that, I mean, you need to read from your dashboard and then introduce on a keypad. You might just skip a number and all of a sudden you are 1,000 miles away. So again, very unreliable source of data. The VIN is even worse, right? I mean, it's a complex number. The VIN, by people that don't know, it's a vehicle identity number that is assigned to every single vehicle, so every single vehicle has a VIN. You might find it sometimes on near your dashboard or under the hood. So it's a big number. I forgot. I think it's six or 7 digits. And it's also painful to introduce it, and again, prone to error. So cards are a pain, and that's where we come into play. So CarIQ realized that if the vehicle needs services, why having a credit card being responsible to pay for those services? Why not having the vehicle itself pay for its own services? And that's what we do. And under the hood, the big fundamental concept that allows this to happen, that allows vehicles to be trustworthy to transact, is vehicle data. So we collect streams of vehicle data 24/7, different types of features from the vehicle. The main ones are location, the fuel level on your tank, the odometer, but also engine temperature, the engine on and off. So a bunch of features that we collect in real time, and we utilize that data to first create an identity for that vehicle, and we ensure that that identity is never broken. So we want to make sure that there's no room for spoofing, like having another machine claiming that it is that machine and getting the services. But also, we utilize that data to understand if the vehicle is where it's supposed to be, at the station or at the service station where it's going to get its service, and that that it's allowed to transact only for the amount for the services that it needs. So we'll see in a minute with a fuel transaction, but I guess that's what it's there. So if you have a tank capacity of 20 gallons and you have half tank, then you should only be able to transact for 10 gallons, right? So it's pretty simple conceptually, but actually making this work is quite complex at the end of the day. So the platform, the real-time data platform that is under the hood is quite unique, first and foremost, but it's also quite complex to build, and that's what I want to point today to some challenges and lessons learned that at least myself I've learned with my contributions for this platform, which is mostly on the machine identity side of things. And yeah, so let's get to it. This is how the experience looks for the driver. So the driver, basically what it does, it opens an app on his phone here, and it gets to select the vehicle. Usually the vehicles are ranked by the distance of the phone to the vehicle, so usually your vehicle is usually like, it shows up on the top. So it selects the vehicle and then navigates to a station. Let's say that it's going to perform a fuel transaction. When it gets close to the station, then the app realizes this vehicle is in the proximity of the station, so it allows the driver to start a transaction flow to get fuel. So it clicks on get fuel on this little button here, and then the next thing that happens is we prompt the driver to introduce the pump number. As soon as the driver introduces the pump number, then within 2-3 seconds, not more than that, the pump unlocks, the driver fuels up, and when the driver closes the pump, a few seconds after, a receipt pops up in the app. And it's as simple as that, no need for more interactions. Now, for us to be able to do that, we are basically talking directly to the merchant. So we are networked into a merchant. We have a big partnership network with different merchants, but we don't cover directly all the merchants possibly right now in the US. So what we also offer is if a driver goes to a station that we do not support, we automatically start a tap-to-pay experience where the only extra step that the driver needs to do is basically tap the phone into the pump, and then it fills up. So the experience is very, very, very similar. Okay, so under the hood, how the machine identity services intervene into this payments flow. And again, what I'm going to describe is a very specific part of this ecosystem. There's an overall platform where the machine identity services are integrated that I'm not going to mention. But if you guys are are curious about the payment side, for example, I can talk about it a little bit up to my knowledge in the end. But from the machine identity services side, so the first thing that happens is, like I mentioned before, we ensure that the vehicle is what it's supposed to be. And we do that by looking into the vehicle data and seeing if there is any big disruption on the data. So if there is a big disruption on GPS, or a big disruption on the fuel level, on the odometer, then we flag that vehicle as, we put that vehicle on quarantine. Maybe something is wrong with that vehicle. If the flow of data, the streams of data look legit, then we let the vehicle transact. So when the vehicle gets near the station, we performed the first identity service that gets triggered is called the proximity score, which we basically ask, is the vehicle in the vicinities of the station? Now, this sounds pretty easy. I mean, if the vehicle has GPS, if we know the location of the station, why just doing a geofence around the station? And if it is inside that geofence, we're good. If we are outside, we're not. Well, it turns out that, and that's where data gets tricky, it turns out that this data sometimes comes with lag. Sometimes there's connectivity issues. So real data is really messy. And what we need to do is, instead of just utilizing a geofence approach, we need to basically be a little bit more smart and understand if the station is reachable from the last time that we heard from that vehicle. So a little bit more intricate, but it kind of like comes with lesson number one, which is data. Do not expect that when you're dealing with real-time data, that data actually gets there in real time. Actually, what is real time, right? So it's even difficult to understand. But always expect lag and absence of data, and build your system around that. So I'll go into that a little bit after. So if the vehicle is in the vicinities of the station, then we let the vehicle transact. The second thing that we do is, like I explained before, we measure the tank level. We estimate the amount of fuel that the vehicle needs. We estimate the cost of fuel in the vicinities of the vehicle, and we underwrite that transaction for a certain amount. So again, if the vehicle needs 10 gallons, and if the price of fuel is $4 per gallon, then we underwrite not 40, but we'll underwrite a little bit more than 40, maybe like 45%, so that we are sure that to cope with some uncertainty. Also another term that I'm going to bring back in this talk. So we underwrite the transaction, we let the transaction go up to, let's say, $45. After the transaction is settled, we still perform another step, which we call post-validation, which is after the transaction ends, and after a few hours, because again, we need to make sure that we collect all the data, we estimate the amount, the fuel intake that got into the vehicle, and we compare with the receipt and see if there is fuel missing. If there is fuel missing, then we will basically declare that that transaction is not valid, and we surface that information to the fleet manager. So this is how it looks under the hood. So this is some like fuel level data from a vehicle. In this particular case, the gray area is the tank capacity. So in this particular case, it fueled up all the way to the top. So the orange line is our estimate of the fuel level, and the blue, which you can't see very well, but it's there, it's the raw data that we get. Again, the data is quite messy and noisy, so we need to clean it up. This happens for a variety of reasons, some of them physically. So what your sensor is doing inside your vehicle is basically a floater, just like you have on the toilet, basically. And that floater, depending on the vibrations of your vehicle, of the attitude of your vehicle, it sloshes and gives you a wrong indication. So that variability that you see over there in blue is basically due to sloshing. There's other issues, again, that comes up with the data. These sensors themselves are extremely inaccurate. Sometimes they get stuck, for example, giving completely wrong indications. So we need to cope with all that uncertainty. Again, I'm going to mention a little bit more later about uncertainty. But in this particular case, we saw that the vehicle got, I guess, around 7 gallons worth of fuel, but 9 got purchased. So there's a difference there. Where did this fuel went? So we pick up this information and wrap it up in a nice way so that the fleet manager can interpret it and decide if there is actual misuse on the platform or not. Sometimes there isn't. Sometimes it might be that this vehicle is carrying an equipment, for example. We work a lot with companies that are construction companies, for example. And the equipment need fuel, and sometimes the drivers just fuel up the vehicle and then fuel up the equipment. So it is still some sort of a misuse of the platform, but from the fleet manager's standpoint, he or she doesn't care, right? I mean, the funds, the company's funds were still applied for the good of the company, so it's fine. So it's not friendly fraud, even though it might be a little misuse of the platform. On those cases, we don't really want to bother too much the fleet manager, so we try to estimate if vehicles have equipment or not. If they have external tanks, for example, it's also something that sometimes happens. Fleet managers upgrade their vehicles to have external tanks to increase the range of the vehicles, and sometimes that can show up as an eventual misuse, but eventually it's not. So how do we surface up this information? So this is again a real case. Each of those bars is one transaction, and the light blue represents the fuel level at the time of the transaction, so before fueling up. The dark blue represents what we estimated that got intake into the vehicle, and then the pink represents fuel that we couldn't account for. We couldn't see it, so we declared that it's missing. So in this particular case, we saw that the vehicle was performing pretty well until a given driver started driving it. And when that happened, then fraud started to happen. Eventually, the fleet manager communicated to the driver, and the fraud stopped. So this is evidence that we changed the behavior of the driver, which is, at the end of the day, what we want. Please go ahead.
Thank you. What does fraud look like in this case, maybe? Is it like some dude's following behind his buddy with a truck and just fuels up his personal truck?
Yeah, so that's a good question. So we see mainly two types of fraud. So the question is, how is it physically performed, how the fraud is physically performed. We saw two cases. One situation where we call tailgating, which is the driver drives the company's vehicle, but asks his buddy or whoever to bring the car to the station as well, and then fuels up one vehicle and then fuels up another, or even just fuels up the private vehicle. Sometimes we see that, and we can see any fuel level inside the company's vehicle. That's also sometimes happens. And the other scenario that we see a lot, that we believe this might have been the case, is the jerry can scenario. So when a driver carries a jerry can and fuels up the jerry can at the end of fueling up the company's vehicle. So those two situations are the ones that we see the most.
Thank you.
Okay, so any questions about fraud and friendly fraud? Yep.
Just one question. For this specific example, why didn't the platform stop them from doing it after the tanking back?
Yeah, so that's a great question. So in this particular case, and I was hoping to get this one. So in this particular case, we see that the green line is the tank capacity. So as I explained before, the platform enforces the transaction to always only go up to a full tank. Now, those controls are controls that the fleet manager can turn on and off. We always we have all these controls available, but at the end of the day, it's always the fleet manager's decision if they want to be more conservative and turn all the controls on, or if they want to be more loose because they don't really want to get bothered with like false positives and at the pump, let's say, and they would rather handling fraud post-transaction. So in this particular case, this fleet had the proximity score turned on, so the location the vehicle had to be at the location to be able to transact, but it had what we call dynamic pre-authorization turned off. So often in these cases, this is the sort of evidence that we show that eventually we also make the case to turn some of these controls on.
I understand how it works when you go to an authorized gas pump. When you go to one that is not authorized, you don't have all the data, no? So how do you manage purchases in that specific scenario when you don't have all the data?
So the question is, what if if the station is out of our network and we use tap to pay instead of using direct connect? The flow from the vehicle standpoint is exactly the same. So the only real thing that changes is on the payment side. So for me, for the machine identity services, I do not differentiate the transaction that is tap to pay or there is direct connect. For us, it's exactly the same. So the data is there. The only real data that we need is the gallon amount from the receipt, and that we get it regardless of the situation, because the vehicle data is always flowing through the telematics provider that we connect with. Another interesting. Oh, go ahead.
I was going to say, just following up on that. So, like, what happens if they go to a gas station and they're out of like the network range? Like, you can't get real-time data because they're just in the middle of nowhere.
Yeah,
And
that's
then
it.
you can't run those analytics.
Yeah.
What do you do?
Great question. So the question is, what happens if the vehicle is out of network? I will approach that question in a little bit. It's one of the lessons learned that I want to present to you guys. So great question. I'll get back to you. So another thing I want to point out here is, which is kind of interesting when you want to change behavior. We also see some situations, not in this particular case, but in a more recent case, where one driver starts committing fraud. And I can actually use the term fraud because in this particular case, the fleet manager decided, yes, this was fraud. And by the way, that dude ended up being let go. So one driver starts committing fraud. All of a sudden, we see all other drivers also getting into a fraudulent behavior. And the inverse also happens. So there is a deterrence effect. As soon as someone gets in trouble, there's a group sort of behavior that happens. So fraud sort of like settles. So bringing a little bit of my military background, there's a deterrence effect that happens just from the fact that the system exists, which is very interesting. And yeah, so it's utilizing car IQ is not just about detecting fraud. It's also mitigating it just from the fact that you're using it, which is, I think it's a great for our clients. Okay, moving on from fraud, another interesting thing that we do with vehicle data, and that one is actually the project that we proposed for your practicum, is we're collecting this vehicle data 24/7. So we know where the vehicles end up transacting, even when they don't transact at car IQ. Even if they transact outside, we still know if they transacted or not because we collect all this vehicle data and we can see. I mean, if the fuel tank goes up, then this vehicle transacted. So we know when, where, for how much, which merchant, what time of the day, what day of the week. We have all this information. And now we are starting to utilize that information to produce yet another product that, excuse me, that can also be utilized for fraud, but the main purpose is another. So, given the fact, since we have all this data, we can now predict the likelihood of a vehicle to transact. Now, you might think that, a vehicle is likely to transact when the tank is getting empty. That's actually what happens with most of people. They go to the station when the tank is empty. Turns out when you have a fleet, usually you have policies in place that sort of makes that assumption a little bit weak. So think of, for example, rental companies. They always require you to deliver the car full, right? So it doesn't really matter if your tank was 70% or 80%. Before handing the car, you have to deliver it full. So the fuel volume is not necessarily a good feature to correlate with is this vehicle likely to transact or not. Some other aspects are. In some fleets, they have policies just like I explained. At the end of the day, please fuel up your vehicle so that in the morning there's no disruption on like going to a gas station. The people can just move on and get to work. Other fleets do the inverse. They actually take the opportunity for fueling to do their daily briefs. They do it at the gas station, they fuel up, they do their daily brief, and then they move on. So there's these patterns that we realize by just looking into the data, and now we find that there's an opportunity to learn these patterns. So that's where we started this project, where we basically implement a machine learning model to learn the likelihood to transact. And when I say likelihood to transact, the dependent variable here is you can think of it as, is this vehicle likely to transact, given its current state, is this vehicle likely to transact within X amount of time? Let's say, is this vehicle likely to transact within an hour? Right? Now, this is interesting for two situations. The one that slightly connects to fraud is, if a vehicle was not likely to transact, but it did transact, then it's also something that you can surface up to the fleet manager. So again, if a vehicle transacted at 5 a.m. on, I don't know, on a weekend, and that never happened, then it might be an anomaly that we might surface up to the fleet manager. Or if the vehicle usually transacts within a certain region, but all of a sudden it's transacting on a completely different geographical region, also an anomaly that we might want to surface up. But the main aspect that we want to explore with this system is actually to provide the service to our merchant networks, so that they can incentivize the drivers to transact at their stations. So if we declare, okay, this vehicle is likely to transact, by the way, it usually transacts at merchant A, hey, merchant B, why don't you incentivize this driver actually using our app, so that it, instead of transacting at merchant A, transacts with you. So, for example, if merchant B has a convenience store, for example, they might send up some incentive like a coffee in the house or something like that. So that mechanism for being able to incentivize drivers based on real, like, historical data is quite unique, and it's something that we want to pursue quite aggressively, and hence the practicum that we are launching. We already have some products, some models developed around it, but we really want to take it to the next level, so we're excited with this opportunity to work with some of you guys. This is some examples. Just out of curiosity, on the left, that's just, one particular instance where there's one particular vehicle that is likely to transact, and that's the target station that we had identified. That's not very interesting, actually. I should remove that. But on the right-hand side, I think that plot is quite interesting. So in this particular case, I'm presenting a heat map for using just two interesting features, but I could have chosen others, which is the current hour of the day and the current food percent. And this is not just for one specific vehicle, it's for the overall fleet. So this is, again, when you start seeing those patterns emerging. So in this particular case, what this is telling us is this particular fleet usually transacts when the vehicles are around 20 to 30% and between 7 to 10 a.m. So again, I'm just presenting two dimensions, but you can think that, there's a bunch of other features that you could basically slice and show it. But I think this one is interesting in its own. Oh, sorry, go ahead.
Talk about the machine learning. Can you talk about you regression or machine learning in this case? How big of a model do you need? Is it simple? Is it complex?
So the model, it's been an interesting. So again, the question: what kind of model are we utilizing? If we're utilizing a regression, classification, machine learning. We've been exploring a lot, and that's some that is still, I would say, still under research. The model that we implemented here was a machine learning model, and we use it mostly as a classification problem. So the question that we posed was, is this vehicle likely, like I said before, is this vehicle likely to transact within, let's say, 10 hours? And the output of the model is yes or no. And the features are the ones that I presented. So we collected a bunch of, we featurized all the data that we get, all this vehicle data, all the transactions events that we get. We featurized them, we feed it into the model and learn these patterns, basically.
On the project you were mentioning before, maybe I didn't understand correctly, but isn't there a bit of a conflict of interest if your client is the fleet manager at certain companies, you want to minimize their costs in a way, and then service stations offering incentives to the drivers to use like the stations, maybe at a higher cost. I don't know. But would you
Yes.
expand on that?
So the question is there a conflict of interest between our primary customer, which is the fleet manager, and the merchant? I can see that being an issue. The way that I approach these systems is always customer first. So always be faithful to who gives you the most revenue, which is in this case the fleet managers. So whatever we are introducing here, we always give the opportunity for the fleet manager to turn it off and on. And that's how I see this being implemented as well. At the end of the day, we always have to be faithful to your fleet manager. So if your fleet manager says, "Oh, I don't care if my driver gets a coffee on the house, as soon as it's not gonna disrupt too much, whatever I mean in terms of cost and also in terms of distance to the station, because if we are saying, oh, okay, go to this station instead of that station, you might be driving more, for example. So we need to take that into consideration and surface that up to the fleet manager and let them decide. By the way, the other point where we want to explore to utilizing these services is also from a low-cost perspective. So that's actually a good point. We also want to, after we understand that the vehicle is likely to transact, we also want to explore which station is the most cost-effective for you to transact. So if there's a cheaper station, so if you're driving on a highway, usually on highways, stations are a little bit more expensive. If you get out of the highway and fuel up at this local station, given the fact, considering the distance, again, the time that you spend during that extra trip, do you come up with a more cost-effective way for your fleet manager? So that's also something that we want to do. And in that particular point, what we want to do is basically surface up this information to the driver as a notification. So hey, we know you're likely to transact. Why don't you go to station A, and save some bucks to your company? So that's also something that we want to explore.
You mentioned just now like service information to the driver, and then earlier you mentioned like fraud detection. Are there any? Do you guys provide any other behavioral mechanisms to let the driver know you're watching, so they don't want to predict?
Yes.
So you don't have this tail-end effect that if one person notices, everyone gets in line. Or like
Yes.
you have like nudges, I guess.
Yes, so the question is, if we surface up from the fraud perspective, if we surface up to the driver information that enables them to understand that there's a pattern happening here, and you might want to correct that someone is watching. So again, this comes up with the deterrence effect situation. So we definitely are exploring that. Right now, we don't surface up anything. The only, let's say, implicit situation that you can feel is when you're filling up, if you try to fill up another vehicle, and if you have dynamic pre-off turned on, then the pump will shut off. And then you'll say, hey, wait a minute, what happened here? Why can't I just like pump more, right? So there's that little feedback, but right now we want to be able to give this information to the fleet manager so that they can understand where are the bad apples here. So for the current clients that we have, that's more valuable. For some clients that I can see that they don't want to deal with that situation at all. So for those clients, for sure, surfacing up to the driver, hey, we got something fishy here. That's probably better, because then the fraud will end up like going away on its own. Please.
So I have a question following Rafa's question earlier about launching a feature, and then you're saying that as a company, our goal is to serve the customer, having a low cost, so they save more money. when it comes to launching a feature from a general perspective, how do you apply, okay, this feature is good and ready to be shipped to as a product, especially knowing all the fleet management have a different behavior. Like even if you do A/B testing, it's difficult to generalize.
Yeah, yeah. That's a good question. So, so how do we choose to launch a feature that basically works the best for the interests of our clients? So, we try to involve them as soon as possible. We have the what we call our champions on each of the companies to give us feedback as early as possible, and we utilize a lot, so engineering works very, very closely with customer success to get to feel the heartbeat here. Are they gonna like it? Is this something that will interest them or not? So I would say we try to involve our customers as soon as we can. Maybe right now we can do it because we are still a small company. But for sure we do that, and the main way that we get that information is through our customer success team. All right, so now jumping into the lessons learned, and some of those I already mentioned or unveiled a little bit, but I want to be a little bit more specific. One of them is uncertainty. And this one I got exposed a lot during the time that I was heading the metrology lab of the Portuguese Air Force, which is a lab that performs calibration of measurement equipments that are used to maintain aircraft, all the aircrafts in the Air Force. And so aviation maintenance is extremely specific. And as you would expect, the uncertainty needs to be reduced to a bare minimum when you are maintaining an aircraft. So in this particular case, for example, I was working at an airbase that maintains and operated the F-16s, which is our fighter in Portugal. And one particular instrument that was extremely critical that we had to calibrate sometimes in some cases monthly, is a very humble torque wrench. So a torque wrench, I don't know if you ever watch it, it's basically just a little wrench that you can set up a torque, and it only lets you apply that specific torque, no more nor less. And it turns out this utilizing torque wrenches that are badly calibrated is an issue that exposes aircrafts to eventual accidents. So that's why these equipment were calibrated on my lab very periodically. And one thing that we had to be sure is not only to determine the errors that the equipment has, but also measuring the uncertainty of the measurement process. So whenever you're measuring something, you're always introducing uncertainty. There is no such thing as 100% accuracy. And you should be able to model it. So you need to model it, and it has to be dynamic, meaning that it depends upon the context. So for example, in this particular case, this is a mechanical equipment. There's springs inside it. So for example, temperature is a big source of uncertainty. So utilizing an equipment, a torque wrench here in California, or utilizing it, or maybe in Arizona, and utilizing it in, I don't know, Michigan, that might be completely different. They might behave differently. So you need to model all this uncertainty, and that's the main part. Make it part of your decision making. In this particular case, the decision making is this torque wrench good to be utilized on the maintenance or not? So that's an easy one. Should we use it or should we throw it away? For complex systems, you need to think a little bit more and understand the impact of the uncertainty. But always measure it. Whenever you're measuring something physical, always have a sense of what is the uncertainty of what you're measuring, and make sure that you make it part of your decision making. In this particular case, again, this is a fuel level plot where you can see that the line, like the orange line, is a little bit under what we are expected. But in this particular case, for this particular vehicle, the uncertainty is quite high. So in this particular case, we're not declaring that there is like an eventual friendly fraud here. We're just saying, well, we need to give the benefit of the doubt to the driver because most likely this is just uncertainty coming from the measurement pipeline. Another interesting lesson that I've been, that the motivation comes from my background on robotics and on developing drones, is always try to find a feedback loop. So if you ever took a class on control theory, you talk a lot about feedback loops, and the main reason to have a feedback loop is, again, to reduce uncertainty on your system. If you don't have uncertainty of your system, you don't need a feedback loop. You can use what it's called like open loop control. But if you have uncertainty, and usually you do, because again, there's no such thing as 100% accuracy, then make sure that you find a feedback loop on your system that can make your system correct itself and try to minimize uncertainty. So this is a quote from Donella Meadows, which was a professor at MIT, and she was a systems dynamics professor, and by the way, she wrote a book that is called Thinking in Systems, which is an amazing book I definitely recommend. And she quotes that missing a feedback loop is one of the most common cases for system malfunctioning. So find your feedback loop and use it to correct your results. So one specific case where I found this implementing these systems was, well, in some situations, we saw situations like these that we thought that it was fraud. And again, just from the plots that I showed you before, this will indeed look like fraud. But actually, it turned out that it wasn't. It turned out that we just had the wrong tank capacity on file. So the data that we get from the fuel level, the fuel volume data that we get is in percent, from 0 to 100. So we need to convert it to gallons, we need tank capacity. And if we don't have the right tank capacity, then we might end up committing an error. So what we end up doing by, understanding this issue is to create an estimator for tank capacities that gets better and better while the vehicle transacts the most. So while the vehicle transacts, we estimate the tank capacity. So we might get it wrong, we might get some false positives at the beginning, but then eventually we will get better. Another one that this one I couldn't really use as motivation, aviation, because on aviation you can't really crash. I mean that's really the only thing that you couldn't do. But I bring a little bit of another motivation from martial arts, which is another activity that I like a lot. If you have done any like grappling martial arts like judo or jiu-jitsu, the first thing that you do, even if you go now to a class, first thing that they do is to teach you how to fall. Because if you don't fall properly, you might hurt yourself. I kind of like this analogy, and the idea is embrace crashing. So if you're building a system that is going to operate under, the system is complex or is operating under a lot of uncertainty, expect the system to crash. And if that happens, then you should design your system around these concepts. So how do you make it more robust to facing a crashing, to react upon it? For example, constructing the system in a more decoupled way with small components, make them reactive instead of, again, tightly coupled. create an after the fact process that understands what happened and try to get better from the next time. And also always identify what is your critical path. For example, for us, our critical path is a driver needs to be able to leave the station with fuel. At least a good driver, not a bad actor. So that's our critical path, and we need to make sure that that's always the case. So always identify your critical path. All the rest can crash, but that part needs to happen, and make it as robust, as performant as possible. So again, going to your question about connectivity. So if in our case, if the vehicle is driving in the middle of nowhere and the connectivity is lost for a good amount of time in a way that we can't even estimate where the vehicle is, because if it is for just a little bit, we can still estimate what is the state of the vehicle. So imagine if you are traveling, like navigating on your vehicle and you go under a tunnel. I mean, if the tunnel is not too big, Google Maps still gives you some estimation of where your vehicle is supposed to be. But if the lag or if the absence of data is too big, then eventually you can't really say, I don't know where, you can't really tell where is this vehicle. So when that situation happens, our system turns that vehicle into an offline mode. Offline mode means we're going to let you transact. We're going to tighten some controls in terms of the dynamic reauthorization. So in this case, we are not going to rely upon the fuel level of your tank because, I mean, we don't know it. So we're going to say, well, you're going to be able to transact for a full tank. We're going to assume that your tank is empty. And we're going to limit the number of transactions that you can perform per day in offline mode, and also the total spend that you can perform. So we tighten up so that we still reduce the events of fraud during the offline mode, because again, it might be the case that a driver is forcing an offline mode so that you could do something fishy. And we let it go. And why we can do it, because again, we have another phase afterwards where we post-validate the transaction, because eventually the data needs to come back. Even if a driver disconnects the vehicle for some reason, and then eventually it has to connect again, because otherwise it will not be able to transact. By the way, we also limit the number of times that the vehicle can transact on offline mode, so that's another thing that we do. And then we perform fuel validation, and we understand, okay, was there room for fraud or not? If there wasn't, then it was a legit offline mode. If there is, then again, we further investigate because there might be room for the driver to try to trick the system. Okay, so last lesson learned is about operations. So if the phrase I'm using here is, if you're building a plane, just get to know your pilots. So those pictures are from the times that I was not an engineer. I was not developing these drones. I was actually part of a team that was spent their summers flying long-range drones to detect wildfires and help managing firefighters during wildfire season. It was a great experience for me, and where I learned a lot, and that I draw a lot of motivations for my engineering career. Because even though I was more than 20 years in the Air Force, I never really wanted to become an operations person. I love airplanes, I love flying, I used to fly gliders, but I was always an engineer at the core, and only when I joined this team as mission commander, that's when I got to appreciate what operations is. So get to know who is flying your pilot, and get to know who's maintaining it. Usually who's maintaining it, I mean, the main person might be you, but there's also DevOps guys, there's infrastructure people, so there's get to know them. And who's actually flying your plane? Is it customer success? Is it solely your user? Might be. Is it sales? Is it the management layer? So get to know them and put yourself on their shoes whenever you can. And I guess own your system end to end. So don't only think that, oh, I'm going to implement this machine learning model, I'm going to expose it as an API, and then that's it. My job is done. No, you need to basically own the overall stack. Well, at least that's how I see it. You should own the overall stack all the way to who's actually operating my system. This means documenting it properly at the right level of abstraction. So if you are documenting things to the DevOps guys, which are very technical, probably even more technical than you, then you need to go to learn those technicalities. But if you are talking to the CEO or to the customer success, then the language needs to change as well. And so be mindful who is responsible to operate your system, and help them as much as you can. For these particular systems that I've been presenting today, the my two main pilots are customer support and customer success. Customer support for what happens at the pump. Customer success for ingesting all this information and helping the fleet manager to decide, to navigate all this information and decide if there was misuse on the platform. All right. At last, we are a pretty fun crew to work with. It's not all about vehicles and payments. We also have fun. We work very closely, 150 California, so it's pretty close. We're neighbors. We love motorsports. I mean, our CEO was a racer back in the days before the Car IQs and another company that he founded. Yeah, so we also have fun and enjoy teamwork, enjoy building a strong team. Like my CEO used to say, the first 40 of a company are the most important people. They're the ones that carry the spirit of the company and make it go further. So that's, we take that serious. And that's it. That's all I had for you guys. Thank you a lot.